Hey, welcome back. I am going to be doing my third KSP tutorial now, and the subject will be landing. So, my first tutorial I covered from launch to landing, getting to the moon, and I showed you that process and how to do orbital maneuvers. Based upon some comments I got from that and some of the things I've read in the forum, and plus paying attention, to what I actually put together, I realized one thing I didn't really cover in my voiceover at all was how to actually land. I mean, you saw me land, but I didn't talk about the particular maneuvers I was making in order to get a soft landing. So I thought I'd cover that today. So this is going to be a shorter tutorial. I'm going to focus only on landing. So I've got my same generic lander over here that I showed you last time. You can see there's Kerbal and there's Moon. So I've already put myself into orbit around min-miss here, and I'm going to start with min-miss because it's easier. So the descent rate is slower, which means that I can do everything in slow motion, and you can watch how I do it. All right, so I'm going to try to walk through landing step by step, the moves I make with the controls, and how that affects the spacecraft. And then once I do it here, I'll go launch the same vehicle up about 10,000 meters and bring it back down on one of the hardest places to do a powered landing, which is Kerbal, because of the gravity field. Alright, so here we go. I'm in orbit. Next step is to actually land. And one thing about landing on these little planetoids is they've got some very big rough patches on them, and landing on a slope is difficult, perhaps impossible if the slope is strong enough. So I'm going to actually do a burn here to aim for one of these flat spots. So let's start there. I'm going to start by putting us in a retrograde orbit, or retrograde position. So you can see on my nav ball over here, I'm going to fly without MechJib this time, so you can see me do it manually. There's my retrograde marker, and I'm going to make a burn in the retrograde direction to start with. And that's about right. So here we go. Doesn't take much thrust to do things quick on min-miss. Alright, that's about right. I am deliberately going to overshoot at first, because you'll see when I do my my deceleration burns, that tends to move this in. I'll show you why. I'll explain that as I go. I also want to move this south a little bit. So remember that normal plus normal minus command I showed you over here? To manually get that, I want to center my nav ball and then go 90 degrees this way. I think it's this way. We'll find out. That's going to be right about there. I probably overshot a little bit because this guy appeared. So we're going to look for where that occurs, where that transition occurs. We can call that 90 degrees. Oh, and I went the wrong way. So we got to flip over to the South Pole. Yeah, I want to burn towards the South Pole. I was burning towards the North Pole. Just a little bit of thrust, so you can see I'm thrusting in the normal minus direction, and I'm inclining my orbit. So I'm aiming for that big flat spot. Now, I showed you last time you can aim very precisely, as I did in the moon example, but, we don't really need to do that here, so I'm not going to worry about it that much. Alright, why do I have that window open? Why do I have that window open? Alright, here we go. So we can see we're at the top of our orbit. We're going to be descending. This isn't a very flat trajectory like I did last time. Sorry, not a very vertical descent. I'm going to actually have quite a bit of horizontal motion coming in as I approach this spot. So let's speed up time a little bit. Quite a bit, actually. Get a little closer. You can see up here my altitude. I'm going to still use this because it's just nice to have. And what I'm going to do at about 50K, this particular case, where you need to do your burns, that's something you need to plan. I'm not going to focus on that in this particular tutorial. Rather, I'm going to focus on the actual landing procedure. So the first thing I'm going to do is kill some of my horizontal velocity and arrest my descent a little bit, but not a huge amount, because I actually want to be, I don't want to be up here forever, and it takes a long time to decelerate on Kerbal. So right now I'm going to just kill my horizontal velocity. So why am I pointing in this direction? Well, you can see my nav ball indicator indicates that I am falling. If I were to point in this direction here, my nose, I would be pointing tail first into my descent vector. So this would slow me down perfectly. But I don't want to slow my vertical component, just my horizontal component. So if I go to this position here on the nav ball and rotate to an even keel, and then I go directly up from that to the horizon, this is the velocity vector right here that will cancel out my horizontal velocity without canceling my vertical velocity. And we'll watch that. So I'm going to set the SAS there, and then we can watch it here. I'm going to burn, and you'll see it's going to bring the arm of this leg inwards. See that? So I'm killing my horizontal velocity but leaving my vertical velocity, because quite frankly it takes a long time to fall on min-miss, and I don't want to kill my vertical velocity yet. So I've just turned that big horizontal approach that I showed you earlier into essentially a straight down vertical approach. Alright, so far so good. Now might as well point my nose up to prepare for the last little bit of this. Might as well drop my landing legs as well. I'm going to flip around, and as a stopgap measure, I'm going to hold my nose like this. So you can see now my nav ball indicator points right there. So so you can see I'm almost falling exactly vertically, which is what you saw on the map. But of course I'm falling pretty quick, so I still have some horizontal velocity, probably too much to land. So we'll worry about that in a little bit. But right now I'm still 40K above the surface, and this lander has plenty of delta V, so I'll cancel the rest of it later. So I'm going to speed up time a little bit. You can see I'm falling. Let's make our next burn around 10K. Now, of course, where you make these burns, again, depends on your lander, what moon you're landing on, etc., etc. If I were doing this on the moon, I'd be coming to, and without having done any vertical burns at this point, I would be coming in at like 500 meters per second, and that might be a little hairier. But here, well, watch, I can cancel this out pretty quick. So I'm going to drop it to, I don't know, 30K or so, 30 meters per second. So. And I'm just going to show you. See this thing's moving along the nav ball? That's because right now my vertical descent velocity is probably about 10 meters per second, and my horizontal velocity is also about 10 meters per second. So you can see, now you can see that there's appreciable sideways direction. In fact, if I look straight down, you can see it. So what looked like essentially a vertical descent isn't. It's got appreciable horizontal components. But we can use those horizontal components, or we can cancel them. So I don't want to land over here on this cliff. I want to land over this way. You can see the nav ball tells me I'm drifting in this direction, and I can see by eye I'm drifting in this direction. So why don't I rotate this around so they match? So now it's a little easier to think about it. If you practice this, if you fly by instruments, you don't need to do that. But I'm going to show you that just as a saving trick. So if I'm going to rotate my spacecraft this direction, you can see I'm going to cancel my velocity vector, the horizontal velocity vector that I want. If I were to go this way, I would push myself more in that direction, and so on. So I'm going to actually do the opposite. I'm going to go over here, and I'm going to cancel that velocity, plus some of my downward velocity, and at the same time, I'm going to go too far. So I'm going to actually move that to the other side of the vertical dot, and now I'm going to be drifting in this direction. I'm going to be drifting that way. In fact, let's do some more. My point is, especially on these really light moons, you can